My name is Uzi, and I'm a data engineer in here in Berlin. And so I was getting some requests on my channel from some of my few viewers, like to make data videos about data engineering and how to become a data engineer, and the technologies and knowledge and information required to become a data engineer. So here is a 101. I'll try to keep this video short as well, I create another video first, and it was like 54 minutes long, but I forgot to record the audio for that video, and yeah, went to waste. But try not that this video is not 54 minutes long or an hour long, but like less. So yeah, Data Engineering 101 by yours truly, Uzi. Moving on. So this is the agenda for today. As you can see, what's data engineer, all these topics I'll cover today. Not in a lot of detail, as I plan on making a separate video for each of these topics. Moving on, if this video gets at least 100 views, or probably every week. Moving on, so our first topic for today is data engineer. What is a data engineer? As you can see here, these are the tasks that a data engineer needs to perform. A data engineer is a job, uh, and the worker responsible for data engineering needs to know data integration, data platform, data ops, like DevOps, and creating pipelines, databases, needs to perform some kinds of analytics on the data and data monitoring, what's going on your pipeline and your integrations, and quality checks on your ingestions. These are the skills needed, like in a map: software engineering, big data skills, programming skills, a bit of ML deployment skills, data engineering, and database skills. A bit of business and ML knowledge and statistics knowledge is also good to have, but not a must. Moving on, a data analyst. So in this video, I'm trying to cover all the paths that you can take if you want to get into the field of data. So starting with data engineer and then now data analyst. So the role or responsibilities of a data analyst are the following. So the data analyst takes data that has been recorded or collected by a data engineer and analyze the data, interpret it, what is inside the data, analyze the data, clean the data. Well, cleaning comes first before an analysis, but I wrote clean after the analysis here. Well, sometimes you can perform the analysis first and then clean out all the unnecessary details later on. Then obviously when you have data which is in a structured or a tabular format, you need to present it to other people who might not understand a tabular format or the format that you are using. Could be unstructured in files or a hierarchical format, but uh, people might not understand it. So you need to create reports and visualizations of that data and then perform some statistics on that data and then visualize those reports as well. So all these things are necessary to know for a data analyst to know. Could be more, could be less, but these are the ones that I have identified throughout my journey as a data person, a data nomad, so as to say. Then moving on, what is a data scientist and what are the main tasks of a data scientist? So a data scientist is mainly responsible for data mining or extraction. Like for example, data mining or extraction could imply summarization of a text. Machine learning, to create models for machine learning for classification of data or clustering of data or things like that, which if requested upon, I could create videos on it in the future as well. Data pre-processing, which is like data cleaning, but more in a machine learning context, and predictions and regressions, and also recommendations could also be here. So different kind of systems that you can perform after analysis on the data. You can predict results or provide suggestions based on that, or rankings and things like that. So these are all the things part of the work of a data scientist. And obviously, to do all of these things, you need a very strong mathematical You need very strong mathematical skills, especially in derivatives and integrals and regressions and graphs and things like that. But yeah, these are the basic skills that you must have in order to start getting into data science. Plus, you can look at this visual for some more information. Moving on. So, up till now, I've discussed these three topics. Coming up are types of data in the database. So, types of data. So, you have mainly three types of data. All the data in the world could be categorized into these three types. So, unstructured data could include binaries, text files, well, my language people here might say like, okay, text files could be structured data as it has an underlying structure based on language about, for example, English, semantics and syntax trees and things like that. But since this information is not stored in text files, therefore text files are like unstructured data. Unstructured data could also involve image files or audio files or video files as well, which do not have a structure, but they're also still data. Anything that is stored on your computer or cloud or storage is data. So moving on, semi-structured data. Semi-structured data implies there is no schema or relationship between entities. There could be a relationship, but not formally. And these are called semi-structured data, such as JSON, XML, column family, graph, CSV. In future videos, I will discuss these things in detail. Structured data, so data that has a schema and is stored as a table, which implies a row and column format, and and these tables have some relationships between them. Moving on, what is a database? So in order to describe this, I need to tell a little story. So before 1986, all data was stored as just files and huge files of data from different industries or companies or factories, and these files would then have to be read through some programming languages, which would give you pointers. If you know programming, then you know what pointers are, and then these files would have to be traversed through these pointers in primitive programming languages, not the high level ones we have today, but like in olden times, you can say. These seem historical now, but there used to be that kind of time, and in those times it used to be a headache in order to um, have databases based on just files that were completely unstructured, and to get some information out of that would be close to impossible or a very cumbersome and long task. So in 1986, PostgreSQL came up with the first database that had a columnar format or a tabular format, and you can say it was the first structured data where, sorry about the noise if you're listening something in the background, just my chair. Anyway, so PostgreSQL came out. They established the database based on something called a relational algebra. It has rules of sets. Followed the rules of sets and for performing operations such as selection, projection, and unions and joins and merges and intersections, a whole algebra based on sets in order to perform operations on the data. And based on that, they also made the SQL language, the querying language over your tabular data, which I will cover in detail in another video. And well, these days, SQL, you have GraphQL, you have KQL, which is a part of Microsoft. And then the capabilities of a modern database includes many different things like querying of structured and unstructured and semi-structured data as well. So, which is something I might cover in the future based on demand. Moving on. So I have discussed these two things already. Moving on, we will have types of data workloads and OLAP, OLTP data warehouses. So types of workloads. So generally, all workloads implies a job or a work that a data engineer has to do, and it is generally categorized into these two parts: transactional and analytical workload, where a transactional workload implies that you have a lot of reads and writes over your storage. For example, a file system where you do not have to aggregate data, um, but just or do not have to perform any analysis or statistical analysis over your data. Just you have to read and write your data, maybe in like an SQL database. Um, then it is a transactional workload. It is optimized for CRUD, which implies create, retrieve, update, and delete. And this means that for a transactional workload, your system that you are using for your transactional workload must be optimized for CRUD. These are the four major operations that are performed over your database or your system, your transactional workload. Normalization is a topic that I will cover in the future if needed, because right now I do not know what my demographics are. Um, but this course could be for very beginners or people who have some knowledge already. Then you have acid, which is not a drug, I promise. In this case, it implies atomicity, consistency, isolation, and durability, which are four constraints, not constraints, I should say, just features or properties of a transactional workload which have to be present in your transactional workload system that you're using. I will cover this thing in much detail in the future. Excuse me. Then you have analytical workloads. Analytical workloads, as discussed before, data for workload performed by data analyst mainly involves like data, a denormalized data, which means like all of your data in like a single table, all the entities without aggregation. Excuse me. So, moving on. Aggregation, like min-max, averages, and sums or percentages. You have to aggregate your data to get some analysis out of it or statistics out of it. It's called aggregation. So this is also a part of your analytical workload, could be. And so you are reading a lot of data from your storage in order to perform these aggregations or analyses. Therefore, your data store needs to be read optimized. To be honest, I think I should start a podcast since these topics have so much detail in them. Moving on. OLAP. So what is meant by OLAP and OLTP? So OLAP means online analytical processing. Please don't ask me why OL is online is has two letters here and then analytical and processing. But OLAP is online analytical processing and OLTP is online transactional processing. So, but we already discussed here um, analytical processing workload and transactional workload. So what are these things? So these imply the technologies that we use for analytical workloads and transactional workloads. So for analytical workloads or analytical processing, we have systems like Spark, or we have in our database systems things like triggers and cursors and aggregations and analytics tools that we use to perform analytical workloads. And systems that are based on these tools are categorized into the category of OLAP. Um, for example, SQL Server Management Studio or Synapse Analytics, our Data Factory, all of these things which are used to analyze data. these technologies are categorized as OLAP systems, whereas OLTP systems are just your database management systems like SQL Server or MongoDB for unstructured data or semi-structured data, and SQL Server for your structured data, or a file system that is designed for simple read and writes or updates or deletions. All these things are categorized in under OLTP. And then another type of workload, which is becoming more and more popular these days, and is absolutely essential for any rising corporation these days, is a data warehouse. So data warehouse, you can think of it as a database of databases. So whereas a database is a combination of tables, and a table is a combination of rows and columns, a data warehouse is a database or a combination of different or multiple data warehouses. So or databases inside your corporation or your company. So in that way, uh, so you need to analyze data from different all of these databases into and to create analysis for get some kind of reports from them or information from them. So there's a whole different way of modeling a data warehouse. It's a very big topic, and it requires that I create its own playlist, to be honest. But I will cover this in much detail in the future. Moving on, we have what have we left? We have data modeling, which is a rather big topic, and then ETL and ELT, plus one more extra slide which is not written here, but I decided to add it for the sake of my data engineers, my up and coming data engineers. So data modeling, what is data modeling? So as discussed before, you have many different kinds of data, structured data, unstructured data, structured data, and let's say you start working at a new company, or you start working at at a university as a data person, as a data specialist. Now you will be tasked with creating a data platform for your users, for your stakeholders. Now, in order to do that, you need to perform data modeling. So data modeling has these things inside it. So for if you are doing a structured data modeling, maybe for example, you're working at a university or you're working for a healthcare provider, then you identify the entities in your business or your for your clients, and then you identify the relationships between them, which is basically referred to as the ER modeling, and then you create tables and databases and data warehouses on top of that. Or let's say you work at Facebook, or you are working at a networking company and you want to define a database that describes the whole network that your company provides. In that case, a graph database would be much better for you. Or maybe you are creating a data cataloging system that graphically defines all of your the relationships between all of the structural data that you have, maybe like Data Hub or Microsoft Purview. In that case, a graphical representation of data also implies that data is stored in a graph format as well. So in this case, a graph database would be your option. Or if you just need simple lookup of your data based on some conditions or some keys, then a key value pair database like the Cosmos DB table API or Azure table storage would be a much better option for you. So yes, based on your requirements, you need to identify which option is the best for you. And after that, just start the modeling process. So moving on, we have this is the structured data modeling, ER and EER diagrams. So ER means entity relationship, where in these rectangles you see the names of the entities, and then these are the names of the attributes or columns that belong to these entities. And then there is a relationship between these entities. There's also a concept called cardinality, but I will not go into that in this video. Whereas in the extended ER diagram, you see that It's a more graphical representation. Instead of having many different shapes, you have only a fixed shape where you have a box containing all the attributes and then the relationships between these attributes plus data types for your columns or your attributes as well. That's EAR. Then you have data warehouses or data warehouse modeling, which includes star schema, snowflake schema, galaxy schema, which is part of the Kimball model, and there are many other things. I have to create a separate long video for Kimball modeling only, but it contains things like a fact table and dimensions and things like that. So yeah, this is data warehouse modeling, which is very important, I must say, especially these days if you want to become a data engineer. So moving on, we have ETL and ELT. ETL, or each letter here, implies extract, transform, load. So data is extracted from different sources. These sources could be anything, like they could be different databases, or they could be files, or they could be JSON files, or text files, or whatever files. You have to read all of these source data from all of these source systems, integrate it into us, and transform the data into a single structure or schema, and then load that schema into your target. This could be even Parquet files, or it could be a formal or a data warehouse or whatever, but a load system, ETL. So, and it is done in this order as well: extract, transform, and load. Extraction and transformation could be, you can say it's grouped together in a way, but when you're programming, maybe for example in Python or any programming language, then be careful, like a separate file for extraction and then a separate file for the transformation. That would be much better. And transformation, as I said, integration of data, but it could also imply not just data integration, but changing data to get and perform analysis on the data as well during the transformation part. Maybe you want to find out like how much items are left in your inventory and how much items are still there, how many items are still there, and what needs to be ordered in your inventory to make your inventory full as well, and the finances around it. So these transformations you can also do as well. And then the required results are then loaded into a target store. But then you also have something called ELT, where after the data is extracted, it's directly loaded into the target system. And the target should be MPP. MPP means massively parallel processing. And it basically implies that you load the data directly after extraction into this system, and this system should have the capability of transforming the data. That means it has to integrate the data and perform analysis on it as well in a very big way. So it should be capable enough to do that as well. Some examples of such systems are, for example, the Azure Synapse Analytics, or Amazon Redshift, or you can also say that Google BigQuery. These are the kinds of data warehousing systems that support ELT, as they are MPP systems, massively parallel. They provide MPP, massively parallel processing, and a huge amount of underlying systems. Even on Snowflake, you could do that if you have those things ready there. So yeah, that's the basic difference between ETL and ELT. And ELT is mostly required because when you do not have the capability or do not have a system that could transform the data before loading, so you just do the transformation after the loading. So that's why it is needed. Examples I can discuss in future videos if you want me to go into detail about these pipelines, ETL and ELT pipelines. And the penultimate slide for today: technologies required for a data engineer. So this is not an exhaustive list, I must say, but from my experience as a data engineer here in Germany. I think these things are absolutely necessary to learn. So starting with Python, like I know some people out there might be saying like, okay, why Python? There's R and then there's Java and Scala as well. But in the current industry, Python has the biggest support of libraries and a multitude of libraries that provide you a lot of capability to perform extensive data engineering, integration, and transformation tasks very seamlessly. Plus, Python is supported by all the cloud providers as a supported language, so it is best that you master Python before starting to work as a data engineer. By mastering, I do not mean like you must have studied all the libraries that Python provides. Just that you need to know the how to work with Python like a programmer. That's it. And one of these clouds, so either Azure or AWS or GCP. Database management systems, you must know at least two or three basic database management systems and must have already worked with them, or not even work, but you must have extensive knowledge of few of these database management systems. Some examples here are MySQL, Oracle, SQL Server Management Studio, or MariaDB for time series data or temporal data. Then it is imperative that you know SQL. Airflow, if you have worked with Dockers and Kubernetes before, you know you are familiar with orchestration. Then Airflow is a task orchestration system where you have various data engineering tasks. For example, E is the extraction is a single node, and until extraction is not done, you can start the transformation part, and until you transformation is not done, you can start loading. So, and you can have some things in parallel as well, some tasks within these things. So to orchestrate different tasks within your system, your pipelines, you have to use a system like Airflow. So it is quite useful these days and very much in demand. Moving on, visualization tools like Power BI or Tableau or Google Data Studio, not Excel. I mean, some companies still use that, but better to learn a formal system like Power BI, where you can use its capabilities to perform complex visualizations and charts and plots and pie charts and bar charts. If you can master such a tool, then there is a very big market open for you currently. And Git, obviously, I will not go into that code versioning system. And ETL tools like Verscape or Talent, which is optional here, as you can already do all of the ETL or data engineering tasks through the above mentioned technologies. But if you're familiar with any of these tools, then there are still a few companies, not a lot, a few of them, that still use these old tools, but they are very powerful and provide a lot of capabilities. Where with a single click you can perform, no, you can write a whole ETL pipeline. So yeah, they're graphical tools. So it's good if you know at least one of them. Just familiarize yourself with them, nothing more. And in this day and age, especially here right now in 20 at the we are reaching the end of 2023, um a big data system like Spark or Hadoop is imperative to it is imperative that you know or are familiar with big data processing and big data modeling through one of these systems, especially Spark. It is as it is widely used, and each big cloud provider has a very big support for this. So yeah, familiarize yourself with that. And with that said, we have reached the end of this presentation and this video. So I will be very grateful, as this is my first video with my own voice that I'm recording on this channel. If you could please like and subscribe to this video. Leaving a comment is your pejorative, but your prerogative. But it would be great if you could leave a feedback. And if I've made any mistakes, please feel free to criticize me. And please subscribe, as I really, as you know, it is very difficult to become part of the YouTube Partner Program these days and just start earning money through it. So I'm really looking forward to gaining at least 500 subscribers by the end of this year. So yeah, it'd be really great. I would really appreciate it if you just could subscribe to this channel. And yeah, please look forward to more videos, which brings me to my very last slide. Next time, I'll be discussing Hadoop and big data processing and the need for it. Okay, and that's it from my side. Thank you very much. I'm Uzi, signing out. Peace.